Today, we'll go another step beyond proving triangles congruent. Once we prove the triangles congruent, we know any corresponding parts are congruent. And then, if we have the correct corresponding parts congruent, we can go on to prove other things. For example, on this one, we have some information about the triangles, and we're trying to prove that R is the midpoint of segment DT. So what do we need to know before we can say that R is the midpoint of DT?
Triangle DAR is congruent to triangle TAR.
So why is that helpful?
Because they both, if they're equal, then DR and TR are equal.
Yeah, and DR is congruent to segment TR is what I was really trying to ask for. If we know that segment DR is congruent to segment TR, then we'll know that R is the midpoint. So that's going to be our goal. We're going to prove the two triangles congruent so that we can prove DR congruent to TR so that we know that R is the midpoint of DT. So let's take a look. No, that's not what I want. Just as a reminder, if you're doing a two-column proof, you must number your statements and reasons. That's at least in part so that someone who's trying to read it can follow what it is that you're doing. As on the homework, we've got perpendicular lines, so we're going to have right angles. AR and DT intersect at R, so angle DRA and angle TRA are right angles. And that's the definition of perpendicular lines. Since I don't know for certain whether I'm going to use hypotenuse leg or not, I won't say anything else about the right angles at this point. Then we've got an angle bisector. We're bisecting angle DAT, the vertex of which is up here. So that means that the two angles at A are going to be congruent to each other. Angle DAR is congruent to angle TAR. You may notice that when I'm doing that, I try to, from the very beginning, match up the corresponding parts. It's not wrong if you say RAT here, but if you do it this way, then you're always matching up the corresponding parts. So that's the definition of an angle bisector. And then I've got segment AR is congruent to segment AR by the reflexive property. And now we can see that it's not going to be hypotenuse leg because I don't have the two hypotenuses congruent to one another. So I do need to say that the right angles are congruent though. Angle DRA is congruent to angle TRA. Again, as it was twice on the homework, because all right angles are congruent. So now we have enough to prove that the two triangles are congruent by angle side angle. So triangle DRA is congruent to triangle TRA by angle side angle. We did that so that we could say that segment DR is congruent to segment TR. By the definition of congruent triangles. And that lets us know that R is the midpoint of segment DT by the definition of a midpoint. Now, normally we think about definition of midpoint when we're given that you have a midpoint to start with, and then we conclude that the two segments are congruent. But remember, definitions are all biconditional. They work in both directions. Any questions about this one? All right, well then let's take a look at this one. I'll do this one as a flowchart proof. So we're given that segment ON is congruent, is parallel, not congruent. To segment HT. And that angle N is congruent to angle H. So what we want to do in order to prove that NT and OH are parallel is prove that, I'm just going to put a little dot in these, that these two angles are congruent to one another. Because if those two angles are congruent to one another, then by the converse of the alternate interior angles theorem, OH and NT would be parallel to one another. All right. So if I've got that these two lines are parallel, then I know that these two angles are congruent to one another. Angle NOT is congruent to angle HTO. By the alternate interior angles theorem. Then what else can we add to this to help us prove that the two triangles are congruent? Yes?
OT is congruent to OT.
Exactly. OT is congruent to OT. By the?
Reflexive property.
Yeah, reflexive property. That's enough to prove that the two triangles are congruent. Triangle NOT congruent to triangle HTO. Who can tell me what reason that would be?
Side,
No,
Angle side.
it's angle side.
Oh wait, no. Oh, it is angle.
If all that's true, then by the definition of congruent triangles, angle NTO is congruent to angle HOT, by the definition of congruent triangles, and if those two angles are congruent, then let me write it the way that they did. NT is parallel to OH. By the converse of the alternate interior angles theorem. Now, you're all smart people. I want you to tell me why I didn't need to do all of that. I could have skipped, 2 or 3 of the steps. How could I have showed that these two angles are congruent without even bothering to show that the triangles are congruent? Yeah.
Because we already know H and N are congruent.
So, these aren't H and N. Ian, you have a thought?
No.
Let me back you up for just a second. You don't need to, don't worry about doing this on your paper or anything, but let's get rid of that. And let's get rid of that and get rid of that. I could have gone straight from here to here. Yes?
If 2 of the angles are congruent, the third one has to be congruent.
Yeah, what is that called?
Third angle theorem.
Yeah, I could have just done the third angle theorem. Very good. And that would have been shorter. I don't think I put any like that on the homework, but I may have. So something to watch for. Okay, questions? All right, I have a worksheet for you.